Let's talk about multidimensional scaling. Learning objectives. Upon completing this chapter, you should be able to do followings. Define multidimensional scaling and describe how it is performed. Understand the differences between the similarity data and preferences data. Select between a dimensional or compositional app approach. Determine the probability and number of objects. Understand how to create a perpetual map. Chapter review. Multidimensional scaling, we call MDS, refer to a series of techniques that help to researcher identify key dimensions underlying respondents evaluation of object and the position these object in the dimensional space. For example, multidimensional scaling is often used to marketing to identify key dimensions underlying customer evaluation or product services or comparison. Other common application could the comparison of physical qualities, for example food taste or various smells, perceptions of political candidates or issues, and even the assessment of the cultural differences between the distinct. Multidimensional scaling technique can refer to underlying dimensions using only a series of similarity or preferences judgment about the object previous by respondent. Once the data are in hand, multidimensional scaling can help determine the number and relative importance of the dimensions respondent use when evaluating object, as well as following the objects are real related perpetually on these dimensions, most often portrayed graphically. Correspondence analysis is related technique with similar objectives. Confirmatory analysis refer to underlying dimensions that can be evaluated as well as the positioning of the object, yet follows a quite different approach. It differs that the similarities and estimated for the cross tabulation table, typically associating objective with attributes. Key terms. Before starting this chapter review the key terms to develop an understanding of the concept and the terminology used. Throughout the chapter, the key appear boldface, other points and emphasized in the chapter, and key term cross references are italicized. Let's talk about the aggregate analysis. Approach to multidimensional scaling, in which a perpetual map is generated for a group of respondent evaluation of objects. This composite perpetual mapping may be created by a computer program or by the researcher to find a few average or representative subject. Compositional method, an approach to perpetual mapping that drive overall similarity or preference. Evaluating form evaluation of separate attributes by each respondent. With compositional method, separate attribute evaluation are composed into an overall evaluation. The most common example of the compositions method are the technique of a factor analysis and discriminant analysis. Confusion data procedure to obtain respondent perceptions of the similarities data. Respondents indicate the similarities between the pair or stimuli. The pairing of confusion of one stimulus with the another is taken to indicate similarity, also known as subjective clustering. Correspondent analysis. Compositional approach, the perpetual mapping that is based on categories of a contingency table. Most applications involve a set of objects and attributes, with the result portraying both object and attributes in the common perpetual map. To drive a multidimensional map, you must have the minimum of the three attributes and the three objects. Cross tabulation table. Cross tabulation of two non-metric and categorical variables in which the entire are the frequency respondent that fall into each cell of the matrix. For example, if three brands were related on the four attributes, the brand by attributes contingency table would be a 3 now by 4 column table. The entire would be the number of times a brand, for example, Coke was rated as having an attribute, for example, sweet taste. Decomposition method. Perpetual mapping method associated with multidimensional technique, including in which this set of the overall evaluation is then decomposed into a set of the dimensions that best represent the objective differences. Degrade solution. MDS solutions, multidimensional scaling solutions, that is invalid because of one inconsistencies in the data, and the second, too few objective compared with the number of the demand icons specified by the researcher. Even though the computer program may indicate a valid solution, the researcher should disagree the degenerate solution and examine the data for the cause. This type of solution is typically portrayed as a circular pattern with the illogical result. Derived measures. Procedure to obtain respondent perceptions of the similarities. Data derived similarities are typically based on set of score given to stimulate by respondent, which are then combined in some manner. The symmetric differential scale is frequently used to elicit such score dimensions. Features on an object. A particular object can be true of a set as positioning both perceived subjective dimension, for example, expensive, fragile, and objective dimensions, color, price, features. Disaggregate analysis approach to multidimensional scaling, in which the researcher generates perceptual map on a respondent by the reportant basis. The result may be difficult to generalize across respondents. Therefore, the researcher may attempt to create fewer maps by some process of aggregate analysis in which the result of respondent are combined. Disparitize differences in the computer generated distances representing similarities, and the distances provide the respondent either the point of perpetual mapping that represent the most preferred combination of perceived attribute according to the respondent. A major of assumptions is that the position of ideal point relative to other objective on the perpetual map would define relative preferences, such as the object further from the ideal point should be preferred less. Importance performance grid. Two-dimensional approach for assisting the researcher in labeling dimensions. The vertical axis is the respondent perceptions of the importance. For example, as measured on the scale of extremely important to not all important. The horizontal axis is performance, for example, the measured on the scale of excellent performance to poor performance. For each brand of the product, service, and various attribute, each object is represented by its value on importance and performance. Index fit square correlation index R square that be interpreted as indicated the proportion of the variance of the disparities, optionally scale data that can be accommodated for by the MDS multidimensional scaling procedure. It measures how well the raw data fit the multidimensional scale model. This index is the alternative to be stress measures for determining the number of dimensions, similar to the measure of covariance in other multivariate technique. Measure of 0.60 or greater are considered acceptable. Initial dimensionality. A starting point is selecting the best spatial configuration for data. Before beginning as MDS procedure, the researcher must specify how many dimensions or features are represented in the data object. Any stimulus that can be compared and evaluated by the respondent, including tangible entities, product or physical object, action, service, sensory perceptions, smell, taste, sight, or even through idea slogans. Objective dimensions. Physical or tangible characteristic of the objects that have an option basis of comparison. For example, a product has size, shape, color, weight, and so on. Perceived dimensions. A respondent's subjective attachment or features to an objective represent its tangible characteristics. Example including quality, expensive, and good looking. These perceived dimensions are unique to the individual respondent and may be little correspondence to actual objective dimensions. Perpetual map. Visual representation of the respondent on the object on the two and more dimensions. Usually this map has opposite level of dimension on the end of the x and the y axis, such as sweets to sour on the end of the x axis and higher price to low price on the end of the y axis. Each object that has a spital position on the perpetual map then reflect the relative similarities of preferences to other subject with regard to the dimensions of the perpetual map. Preferences implies that objects are judged by the respondent in terms of the dominance relationship, that is the stimulate are ordered in preference with the respect to some property. Direct making, paired comparison, and preferences scale are frequently used to determine respondent preference. Preference data. The data used to determine the preference among the objective can be contrast to the similarities data, which denotes the similarity among objects but has no good bad distinctions as seen in preference data. Projection. Points defined by perpendicular line from the object to the vector. Projections are used in determining the preferences order with vector representation. Similarities data. Data used to determine which objects are the most similar to each other and which are the most dissimilar. Implicit in the similarities measurement is the ability to compare all pairs of objects. Three procedures to obtain similarities data are paired comparison of object, confusion data, and derived measures. Similarities scale, arbitrary scale, for example from -5 to +5, that enable the representation of an ordered relationship between the object from the most similar closest to the least similar farthest apart. The scale is the appropriate only the presenting a single dimensions. Stress measurement. Proportions of the variance of the disparities. Optimal scale data not accounted for by the multiple dimension scaling model. This type of the measurement varies according to the type of program and the data being analyzed. The stressed measures help to determine the appropriate number of dimensions in including in the model. Stressed transformation of an multidimensional scaling solution to make the dimensions of individual elements reflect the relative weight of preferences. Subjective clustering, see confusion data, subjective dimensions, perceived dimensions, subjective evaluation. Methods of determining how many dimensions are represented in the multiple dimensional scaling model. The researcher makes a subjective inspections of the spatial map and asks whether the configuration looks responsible. The objective is to obtain the best fit with the latest number of the dimensions. Unfolding representation of an individual respondent preferences with a common aggregate stimulus aspect driven from all respondents as a whole. The individual preferences are unfolded and portrayed as the best possible representations with the aggregate analysis. Vector method of the portraying an ideal points of attributes in a perpetual map involves the use of the projections to determine an object's order and the vector. What is the multidimensional scaling? Multidimensional scaling, also known as the perpetual mapping, it is a procedure that enables a researcher to determine the perceived relative image of set of the objective firm product ideas or other items associated with commonly held perceptions. The purpose of multidimensional scaling is to transform customers' judgment of overall similarities or preferences, for example, preferences for store or brands, into distance and represented in the multidimensional scaling space. Comparing objects. Multidimensional scaling is based on the comparison of objects, for example, product, service, person. Multidimensional scaling differs from other multivariate method in that it is used only a single overall measurement of the similarities or preferences. To perform multidimensional scaling analysis, the researcher perform three basic steps: gather measurement of the similarities or the performance across the entire object to be analyzed. Use multidimensional scaling technique to estimate the relative position of each object in the multidimensional space. Number third, identify and interpret the axis of the dimensional and the term of the perpetual or objective attributes. Assume that the object A and B are judged by the R respondents to the most similar. Compare with all other possible pair of objects AC, BC, AD and so on. Multidimensional scaling technique will positions object A and B so that the distance between them multidimensional space is similar than the distance between any other two pairs of object. The resulting perpetual map, also known as the spiral map, shows the relative positioning of the object as shown in the figure 1. This is the dimension 1, this is the negative and this is the positive one. Multidimensional scaling in figure 1 illustrate of the multidimensional map of the perpetual of 6 industries supplied A to F and the ideal point of UP. Dimensions, the basic for comparison. What is the basic for the relative position of each object? Why were A and B more similar than any other pair of objects? For example, A and D. Why do the axes of the multidimensional space represent? Before we attempt to answer any of these questions, we first must recognize that any object can be thrown off and having dimensions that represent an individual perceptions or attributes or combinations of attributes. These dimensions may represent a single attribute, perception or idea, or may be composites of any number of the attributes. Suppose reputations. Objective versus subjective dimensions. When characterizing an objective, it is also important to remember that individual may use different type of the measurement marketing these judgment. For example, one measurement is an objective dimensions which has quantifiable, physical, or observable attributes. Another type of measures, it is perceived dimensions, also known as the subjective dimensions, in which individuals evaluate the object based on the perceptions. In this case, the perceived dimensions is an interpretations by the individuals may or may not be based on objective dimensions. For example, management may view their product, a low number, as having two color options, red and green, a 2 horsepower motor and 24 in blade, which are the objective dimensions. However, customers may or may not focus on these attributes. Customers may focus on a perceived dimension such as mover being expective looking or fragile. Two objects may have the same physical characteristics, objective dimensions, but be viewed differently because objects are perceived to difference in a quality, a perceived dimensions by any customers. Those the following two differences between the objective and perpetual dimensions are important. Let's talk about the individual differences. The dimension perceived by the customer may not coincide with or may not even include the objective dimensions assumed by the researcher. We expect that each individual may have different perceived dimensions, but the researcher must also accept that the object dimensions may also vary substantially. Individual may consider different set of the objective that characterize as well as vary the importance they attach to each dimension. Interdependence, the evaluation of dimensions even if the perceived dimensions are the same as the objective dimension may not be interdependent and may not agree. Both perceived and objective dimension may interact with one another, create unexpected evaluation. For example, one soft drink may be judged sweeter than another because the first has the fruitier aroma and although both combination the source amount of the sweetness. Relating objectives and subjective dimensions. The challenge to the researcher is to understand how both the perceived dimensions and objective dimensions related to the axis of these multidimensional space used in the perpetual mapping. If possible, it is similar to the interpretation of the variable in many other multivariates technique, labeling the factor analysis, but differ in that the researcher never directly used any attribute rating. For example, rating or quality attractiveness. When obtaining the similarity rating among objects, instead of the research collection only similarity of the preferences. Using only the overall measurement, similarity or preferences required that the researcher first understand the correspondence between the perpetual and the objective dimensions with the axis of the perpetual map. Then additional analysis can identify with attributes predict the position of each object in the both perpetual and objective space. A note accustions must be raised, however, concerning the interpretation of the dimensions because this process is as much an art as a science, the researcher must resist the temptations to allow personal perceptions to affect the qualitative dimensionality of the perceived dimensions. Given the level of researcher input, cautions must be taken to be objective as possible to this critical yet still rudimentary area. Let's talk about a simplified look at how multidimensional scaling work. The facilitates a better understanding of the basic procedure in multidimensional scaling. We first represent a simple example to illustrate the basic concept underlying multidimensional scaling and the procedure by which it transforms similarity judgment into the corresponding spatial position. We will follow the three basic steps described previously. Gathering similarity judgments. The first step is to obtain similarity judgment from one or more respondent. Here we will ask respondent for a single measurement or similarity for each pair of objects. Market researchers are interested in understanding consumer perception of six categories that are currently on the market. Instead of trying to gather information about the customer evaluations and the candy bars on a number of attributes, the researcher instead gathering perceptions of the overall similarities or dissimilarities. The data are typically gathered by the having respondent given the simple global responses to statement such as these. Number 1, rate the similarity or of the product A and B on the 10-point scale. Product A is more similar to product B to C. I like product A better than product B. Creating the perpetual map. From this sample responses, a perpetual map can be drawn that best portray the overall pattern of the similarities. Among these six candy bars, we illustrate the process of creating perpetual map with the data from single respondent. Although this is the procedure could also be applied to multiple respondent to or aggregate responses of the group customers. The data are gathered by the first creating set of the 15 units pair of the 6 candy bars. 6 into 5, 2 is equal to 15 pairs. After testing the candy bars, the respondent is asked to rank the 15 candy bars, where the rank of 1 is assigned to the pair of candy bars that is most similar, and the rank of the 15 indicates that pair that least alike. The result rank order for all pairs or candy bars for one respondent are shown in the table 1. This respondent throughout that candy bar D and E were the most similar, candy bar A and B were the next most similar, and so forth until candy bar E and F were the least similar. If we want to illustrate the similarity among the candy bar graphically, a first attempt would be the drawn a single scale and fit all the candy bars to it. In this one-dimensional portrayal of the similarity, distance represents similarity. Those the objects closer together on the scale are more similar, and those further away less similar. The objective is to position the candy bar on the scale so that the rank order are the best represented. Rank order of 1 is closest, rank order of 2 is next closest, and so on. Let's talk about the table 1. This is shown the data about the similarity data rank orders to the candy bar pairs. Note, lower values indicate greater similarity, with 1 the most similar pair and the 15 the least similar pair. Let us try to see how we would place some of the objects. Positioning 2 or 3 candy bars is fairly simple. The first real test comes with 4 objects We choose candy bar A, B, C and D. Table 1 shown that the rank order of the pairs is the following: A less than AD, BD greater than AD, CD greater than BD. So that's how each pairs of the letters refer to the distant similarity between the pair. From this value we must place 4 candy bars on a single scale so that most similar AB are the closest and the least similar AC are the farthest apart. Figure 2 contain one-dimensional perpetual map. The matches that order AC are the farthest apart. Figure 2 contain one-dimensional perpetual map that match the simple rule of the similarity that involve only one attribute dimensions such as amount of chocolate. Then all the pairs could be placed on a single scale. That procedure the similarity values. Although a one dimensions map can be accommodate four objects, the task become increasingly difficult as the number of objects increasing. The interested reader is encouraged to attempt this task with 6 objects. When the single dimension is employed with the 6 objects, he actually ordering the various substantially from the respondent and original rank order. Because one dimensional scaling does not fit the data well, a two-dimensional solution should be attempted. It allows for another scale dimensions to be used in configuring the 6 candy bars. The procedure is quite attempt by hand. The two-dimensional solution procedure by MDS program is shown in the figure 2b. This configuration match he rank order on the table 1 exactly, supporting the notice that respondent most probably use two dimensions is in evaluating the candy bars. The conjectures that leads to attribute dimensions were considered is based on the inability to represent the respondent perceptions in some time solution. However, we are still not aware that attributes the respondent use in this evaluation. This is the dimension 1 variable uh, B, A and D minus 2 two-dimensional perpetual mapping. One dimensional perpetual mapping has the one line, the two dimension, the plus and minus, the plus sign, the one and two dimensional perpetual map. Interpreting the axis. Although we have no information as to what these dimensions are, we may be able to look at the relative position of the candy bars and interfere what attributes that dimension represent. For example, suppose the candy bar A, B and F were from the combination bar chocolate and peanuts. Chocolate and peanuts butter and CDE vertically chocolate bar. We could then interface the horizontal dimensions represent the type of the candy bar chocolate versus combination. When we took at the position of the candy bar of the vertical dimension, other attributes may emerge the descriptions of the dimension as well. Multidimensional scaling enables researchers to understand the similarity between the objective. Suppose candy bars to be asking only for overall similarity perceptions. The procedure may also assist in determining which the attributes actually enter into the perceptions of the similarity. Although we do not directly incorporate the attribute evaluating into the multidimensional scaling procedure, we can use them in subsequent analysis to assist interpreting the dimension and the impact and the attributes has on the relative position as the candy bar. Comparing MDS to other interdependence technique. Multidimensional scaling can be compared to the other interdependence techniques such as factor and the cluster analysis based on its approach defining structure. Factor analysis defines structure by grouping variable that is two variate that represent underlying dimension in the original set of the variable. Variable that highly correlated are grouped together. The cluster analysis defines structures by grouping the object according to their profile on the set of the variable. The cluster variate in which the object is closer appropriate each of the group together. Multidimensional scaling differs from the factor and the cluster analysis in two key aspects. Number one, solution can be obtained for each individual, and two, it does not use a variate individual as the unit of analysis. In multidimensional scaling, each respondent provides evaluating of all objects being considered so that a solution can be obtained for each individual that is not possible in cluster analysis or factor analysis. As such, the focus is not on the object themselves but instead of how the individual perceives the object. The structures being defined in the perpetual dimensions of the comparison for the individual. Once the perpetual dimensions are defined, the relative comparison among the objects can also be made. Lack of the variate. Multidimensional scaling, unlike the other multivariate technique, does not use a variate. Instead, that variable that make up the variate, that is the perpetual dimensions of the comparison, are inflate formal global measurement of similarity among the objective. In a simple analog, it is like provide the dependent variable similarity among the objective and figuring out what the independent variable perpetual dimension must be. Multidimensional scaling has the advantages of the reducing and influencing of the research by all requiring the specification of the variable to be used to comparing object as we required in the cluster analysis. It also has the disadvantage that the researcher is not really sure that variable that the respondent is using the make the comparison. A decision framework for perpetual mapping. Perpetual mapping encompassed a wide range of the possible methods including multidimensional scaling, and all these techniques can be viewed throughout the six stages model building process. These steps represent a decision framework despite in figure 3 stage 1 to 3 and the figure 5 stage 4 to 6 within which all perpetual mapping technique can be applied and the result evaluated. Here is the stages of multidimensional scaling. The stage 1 that represent the research problem, select the objective, identify the unrecognized evaluative dimensions, comparative evaluation and objective. That's then the research specification, identify all relative objects, choose between the similarity or preferences data, select a disaggregate or aggregate analysis. Step 2, select an approach to perpetual mapping. Are the evaluate attributes specified by the researcher compositionals or only overall measurement performance used? Decomposition. Compositional method and decomposition method. There are two methods in stage 2. Number 1, the compositional methods, graphical post hoc methods, multivariate technique, correspondent analysis, and decomposition methods, traditional multidimensional scaling technique. Research design is used number of object, metric versus non-metric data. Type of the evaluations made is the respondent describes similarities as the object, preferences between the object or combination of both. Here are the similarities, references, and both similarities and preference measurement. If we talk about the similarities, comparison or paired objects, confusions data, drive measurement. If we talk about the preferences, direct ranking and paired comparison, that will become the assumptions. Dimensionality, and we call it stage 3 of evaluation may vary be respondent. Importance of evaluating dimensions may vary, evaluated need not be stable over time. If we talk about the both similarities and preferences measurement, the combination of the similarities and preferences measurement. Here is the stage 4. Stage 1 to 3, the multidimensional scaling decision diagram. Stage 1 objective of multidimensional scaling. Perpetual mapping and multidimensional scaling in a particular is most appropriate for achieving two objectives. Number 1, an exploratory technique to identify unrecognized dimension affecting behavior. Second, a means of obtaining comparative evaluation of objective when the specified based on comparison are known of unified. In multidimensional scaling, it is not necessary to specify the attributes of the comparison for the respondent. All that is required is to specify the object and make sure that the objects share common basis of comparison. This flexibility makes multidimensional scaling particularly suited to image and positioning studies in which the dimensions of evaluation may be too global or too emotional and effective to be measured by the conventional scales. Multidimensional scaling methods combine the positioning of the object and the subject in a single overall mapping, making the relative position objective and customer segmentation analysis much more direct. Key decision in setting objective. The strength or perpetual mapping is its ability to enter dimensions without the need to define the attributes. The flexibility and the interferential natures of multidimensional scaling places and responsibility on the research to correctly define the analysis, the conceptual as well as the actual considerations essential for the multidimensional scaling to achieve its best result are addressed throughout these key decisions. Number 1, selecting the objects that will be evaluated, deciding the whether the similarity of the performance are to be analyzed, choosing the whether the analysis will be performed the group individually level, identification of all relevant objects to be evaluated. The most basic but important issues in perpetual mapping is the defined object to be evaluated. The researcher must ensure that all relevant forms, product, service, or the objects are included because perpetual mapping is a technique of relative positioning. Relevancy is determined by the researcher questions to be addressed. For example, a study of soft drink must include both sugar-based and sugar-free soft drinks, unless the researcher questions explicitly exclude one type of another. Likewise, a study of the soft drink would not include the fruit juices. The perpetual map resulting from any of the method can be greatly influenced by either the omissions of the object and the inclusion of the inappropriate ones. In irrelevant or the non-comparable objects are included, the researcher is forcing the technique not only to interfere the perpetual dimensions and the distinguish among the comparable objective, but also the those dimensions that distinguished among the uncomparable objective as well. The task is beyond the scope of multidimensional scaling and the result in a solutions that address see neither the quantitative well and likewise omitted a relevant object as per the view true objective and the perpetual mapping. In next video I'll talk about the similarity versus the preferences data.